Is my slide visible?
Yes, it does. Yep.
Okay. Okay. So my name is Mamo. I am presenting the time series forecasting using deep learning.
Excuse me, Tewodos, it's very faint. I'm not sure if I'm the only one who has trouble hearing it. Is there any way you can move closer to the mic?
Let's see. How about now?
Yes, much louder. Yes, better.
Much louder. Okay. So my name is Mamo, and I'm presenting time series forecast using deep learning. Here's a quick agenda. Forecasting is the value of future time steps of sequences by training a sequence-to-sequence regression long shared time memory network, where the responses are the training sequences with values shifted by one time step. To forecast the value of multiple time steps, and finally apply deep learning based time series prediction on some applications such as chickenpox prediction. What's deep learning? Deep learning is currently an extremely active research area in machine learning and pattern recognition field. Deep learning refers to a specialized version of machine learning techniques. For example, companies like Google, Apple, and Facebook collect massive amount of data and analyze it to actually predict the behavior of their users. Why time series forecasting? Because it leverages statistics methods to predict future behaviors based on historical data, to look at data over time to forecast or predict what will happen in the next time period. An example, the most common and basic example is seasonal revenue. Many companies are exploring time series forecasting as a way of making investment decisions. Time series data. The time series is a sequence of data points through time. Thus, when dealing with time series, order matters. Time series data have two important properties. Data is measured sequentially in equal space time. Each time unit has at most one measurement. Time series patterns. Most time series data usually have at least one of these three kinds of patterns: trending, seasonality, or cyclical behavior. So here is an example of trend. A trend can be upward trend or downward trend, or it could be upward to downward trend. It could be down to up trend, or it could be just horizontal. Seasonality. The season pattern is any kind of fluctuation or change in the time series that caused by calendar-related events. Seasonality always has fixed frequencies. A seasonal pattern always starts and ends at the same period of a week, year, or etc. Here is an example of cyclical pattern. As you can see, like the patterns are repeating on a specific period of time. So here is the training data that I have used to do this experiment. Chickenpox data contains a single time series with time steps corresponding to months and values corresponding to the number of cases. The output is a cell array, which each element is a single time step. Here is a visualization of the data. And here is a training model and what is it doing. So initially we can see here that the program or the function or the LSTM network doesn't know what to do, but over time, as it goes through the iteration, that we can see the error is minimized. So basically, this trend is showing RMSE, which means root mean error, which root mean square error, and this is showing the horizontal line is showing the time iteration, or number of iterations. So as the number of the iterations are increasing, the difference between the prediction and the actual data is like dying out. So forecast future time step. So this is an example for that. As you can see, like blue are like the observed values, and at the end, the orange color is the forecast values. And this is cases per time. And here is the forecast value is the test data. So the observed values are the blue lines, and the forecast is the orange lines, as I described earlier. And then the errors are this right here, and those are like here plotted right down in the stem plots. And as you see, the RMSE values are 183 for this one. And when we run the model with operator network state, we observe that the RMSE value goes down from 186 to 136. Thereby, it's reducing the errors. Conclusion time series forecast is an important area of machine learning that's often overlooked. It's important because there are so many prediction problems that involve time component. These problems are overlooked because it is time component that's hard to predict. So I think that it's also because it's analysis actually uses methods and mathematics that are like common in engineering, so they are not available for common people. So the learning curve is high on this. Acknowledgement, I would like to acknowledge like Lockheed Martin for sponsoring this program, and CIS for providing this opportunity, and Dr. Nan Zhang for being my mentor. Thank you, and if you have any question, I'll take that.
Thank you. Tewodros, are there any questions? Well, I maybe have a question, which is,
Sure.
among the time series of interest to human beings, probably the stock market would be one of them.
Yes.
Is this accurate for predicting the stock market?
Definitely. So it all depends on the training data. If we have a good training data, sure. I think that's one of the major area that's actually utilized. Like I think overly used on that area. So that's the one of the area, because this is actually like a signal analysis. So I think it's very common in that industry.
Thank you. There's a question in the chat.
Yeah.
Would you go ahead?
Let me check.
Yeah, this is from Akin Uzegu. Did you use exponential smoothing?
Yes, we have actually the detail is on the in the report, but yes, it does. The system does use exposure smoothing.
Okay, thank you.
Thank you very much.
Well, thank you, Tewodros. So this brings us to the conclusion of our event today. We want to thank all the presenters and all the faculty who advised them. And what it shows, among other things, is that our School of Engineering and Applied Sciences certainly is a vibrant ecosystem for research and for taking learning beyond the classroom. We're certainly grateful to the Lockheed Martin Corporation for their continuing support of this Lockheed Martin Research Fellowship. And it deserves some special recognition that all of this excellent research was done while locked down in this once-in-a-century COVID pandemic. It's a testament to the perseverance and enthusiasm to learn of all the participants. And so we want to thank you again most heartily.
Dr. Nechi?
Yes, Dr. Osasanya?
Yeah, what is the expectation for the report to be turned in?
When you say what is the expectation, you mean?
For reports to be turned in, to be submitted.
Oh, yes. Okay. You mean when?
Yeah.
Okay, so when actually requires time travel because it was the 30th of April, but we'll still take them. If they're done now, that's fine. Just send them in.
Okay, yeah. Thank you.
Okay, thank you everybody for attending and for your interest and for showing your support.
Thank you, Dr. Nietzsche.
Thank you,
Thank
everybody.
you.
Okay, thank you. Goodbye, everybody.
Thank you.
Thank you, Dr. Nishi.